So in this question, we have a graph. So we'll do our Oizerga analysis. Origin 0, 0, we're good. Y-axis acceleration in normal units. X-axis time in normal units. Therefore, we will be able to read off the answers that would relate to questions asking about acceleration or time. The gradient is delta A over delta T, which has units of meters per second squared per second, which is meters per second cubed, and that is the jerk. And the area, A, is A delta T, which is units of meters per second squared times seconds, which gives us units of meters per second, which is delta V, the change in velocity. All right, so the graph shows acceleration for an object that is at rest at time 0. So V0 equals 0. Since V0 equals 0 and the area is delta V, the definition of delta V is V minus V0. And if V0 is 0, then delta V equals V. In other words, the area equals not just delta V, but also V. So you want the distance traveled by the object between 0 and 2 seconds. Well, if we were to find this area, that would give us the velocity at any instant in time. And then we can see the acceleration is 0. So this is constant velocity. So what we have is a change in position that is during this acceleration phase, and there's a change in position during this constant velocity phase. But to find that out, we need to know the velocity at the end. So the first thing we can do for the first 2 seconds is use our position formula. X equals 1/2 AT squared plus V0t plus X0. And if we say the thing started at a position of 0, then X0 is 0. We know V0 is 0, so then X just equals 1/2 AT squared. The acceleration is 2, and the time is 1. Aha, so the position is 1 meter. Now we need to know the velocity to find out what's going on there. So we have V equals AT plus V0, our relationship for velocity. We know the acceleration is 2, the time is 1 second, and the initial velocity is 0, so our velocity is 2 meters per second when we get here. So that, using the average velocity, is delta X over delta T. Delta X equals V bar delta T. And the average or constant velocity is 2, and the time is 2 seconds, so that is 4 meters. Now it appears that if we add these two together, it's 1 meter plus 4 meter would be 5 meters. But the problem is the time that this traveled is not 2 seconds. The delta T is 1 second. So this should be 1 second, and that's 2 meters. So we have 1 meter plus 2 meters equals 3 meters. Choice C.